So here it starts. So we going to use K neighbors classifier as the import submatrix and the matrices accuracy score. So K neighbors classifier, from this import we got this method, and here it is hard coded, but we are going to see how we can get automated results of good K.
Okay.
So we do a feed of train and do predict and got accuracy. So this is done, right? So here we know like this how to do. Number of K, as I said earlier, so neighbors, so 3, 5, 7, any odd numbers will come. Will be good, and it is not very at the higher end also, and very, I mean, it's not obviously not 1 K value, but you can start from 3 to 3, 5, 7, 11, 13, 15, like that number.
Okay.
So let's see how we did it. So we imported cross validation score. The first thing is we want K value, we wanted to get 1 to 70. So list of range of 1 to 70 means just list of 1 to 70. Okay. So we created a list, and the range is 1 to 70. And this is a filter lambda x colon x mod 2 not is equal to 0. So that means, so will be my list. So in the my list, if it is 1, if it is not is equal to 0, then will come in the neighbor. So all the value, all the from 1 to 70, whatever is odd number, will this filter using the lambda method of this. So lambda is some callback method which actually do inline kind of things, do the implementation and return on the same day. So ultimately from this method you are going to get only the odd numbers which are not equal to 0.
0. Okay.
So you will have a list of odd numbers 1, 3, 5, 7, 11.
Okay.
So now we take an empty list. Empty list, correct. Now K in neighbors, all the odd values. First one it will start. Their neighbors classifier. So it has all the list, right? 1 to 70, whatever also. One by one it will take from in the K. And it will put in the K neighbors classifier.
Right.
And we got a KNN, which we used to.
And the cross-well score.
Which used to feed, right?
Yeah.
But here we are not feeding it. We are providing it a cross validation score.
Okay.
So, cross validation score is like this. So if it is a data set is like 100 records are there, first 20 records will be for testing, and the next 80 records will be for training.
Okay.
Then the testing data will be changed to the 20 to 40%, and rest will be training. And then the testing data will change to the 60%, 40 to 60, then here 60 to 80, then 80 to 100. This is the shifting of the test data.
Okay.
So this is K-fold cross validation. So how many times you wanted to fold the data?
Data, okay.
So here we put 10-fold.
10 folds, yes.
10-fold on the data set. We have 156 records, something low. So that we put. And this method will find out the K-fold cross validation, 10-fold cross validation. And you giving a score. Means every time when the first 10% will be taken, So that time, what is the accuracy of the algorithm? Then the 20% will be taken on the data, the next 10%, second fold. Then what is the accuracy score?
Mhm.
So scores.mean will give you CV scores.
So also one question, Jimmy, is like the number of fold decides how much will be in the test. Like how much, like for example, 10. That means there will be 10 buckets of 10% each, right?
10 buckets, I mean, yeah, like, yes. Just divide the data into 10 data set
10 data
and
sets,
take the
and
first.
then like so in the first iteration, the first bucket will be used
Yes,
as a
the
test.
second bucket. Yes, correct. Right,
Then the
right.
second iteration, the second one, the third one, the third one, right?
Yes.
That's how it works. Okay, okay.
So the CV scores is like this now.
Mm-hmm.
Cross validation scores that, I mean, scores the mean value. So now we say, so every time scores is not getting 1. So 10 fold is there, right? CV is equal to
Yes.
10. So if I take K is equal to 1 or 3, so that time there will be 10 times score will happen.
Mm-hmm.
So the whole KNN will work for 10 times.
10 times, yeah.
When the K value is 3 or something 1.
Yeah.
So you got the 10 values of that. So that's why we append the mean of that. That's why we get a mean, not one score. This is 10 score. 10 times you got. And
Mm-hmm.
average we got append into CV scores.
Mm-hmm.
Again, K will be changed. Then again, average of the 10-fold validations will be append to this one. So that if we have 70 variables, 70 numbers, 1 to 70 we do here. So 35 odd numbers will be there, all right? 35 odd numbers will be. So 35 times we got CV scores.
Okay.
So I printed out the scores, which is not one numbers to show you. See, these are not one numbers. 10 numbers should be there because 10 fold with it.
Yeah.
Any confusion?
Mm-hmm. No, that's fine.
Okay. And the CV scores, which is CV scores is the mean of that score, is looks like this one, 94%, 94%, like this.
So like if I understand it correctly, like every time we go through the loop and we have like 10 buckets, so there will be 10 scores which will be created, right?
Yes, it is just like we're doing more iterations.
More
When we take
iterations.
one K value, that time instead of taking one result, we are changing the test and training data 10 times and we're getting 10 results.
10 results, right.
And taking the mean of that results.
Okay.
So when we take K is equal to 1, this is coming. K is equal to 3, this is coming. K is equal to
This,
5, this is coming. 7,
okay.
and so on. So it will give you 35 times.
35 stars, right. And when we are appending the mean, so like can you go up a little bit? So when we are saying CV scores append scores dot mean, that means like whatever the 10 results happen in the scores, it is
Yes.
taking the and appending to
Taking the
CV
mean
score.
of that.
Yeah,
When K is
and
something 1, the mean of the 10 scores we took and we save in a list. And that this is the list. So this list first value is when K is equal to 1.
we will have 35 values because our loop runs for 35 times.
Yes, because of K for this 35.
Yeah. And if I look at the scores, every time it will be 10.
Which one?
The scores, like in every iteration, the scores will have 10 values, right?
CV scores.
No, the scores.
Scores. Yes, scores will have 10
Scores will have
values.
10 values.
Yes. See, scores will
Yeah,
have 10 values. Correct.
and the CV scores will have 35 because for each iteration it will append like one value. Okay.
Correct. Yes.
Okay.
So initially, if you see the k value is so algorithm performance is good, but as it go in higher and higher value, after sometimes it start decreasing.
Yeah.
So going to K35 is going decrease so much.
Mhm.
So now the thing is we got the accuracy.
Mhm.
So we can get the error like this
Mhm.
for X in CV score. This is called least comprehension.
Right.
You understand, right? So for X in CV scores, whatever X is there, that X is taken and 1 minus that X, 1 minus X first time for X in CV scores. Then again X in CV scores second one, 1 minus that one, then third one, and so on. It will give us all the mean squared error.
Mhm.
Because this is mean squared accuracy, right?
Right.
So scores don't mean. So mean squared accuracy, that's why we go mean squared error. So 1 minus accuracy means error. And this is the error for all the 35s.
Yes.
Now, why we do mean squared error is to actually, we have a plot, we need a plot like this. So what is that plot which is? Oh, so, okay, so this is not required, I'll remove it. So there is a duplicate, so I was just wanted to remove that.
Mhm.
Same time, so okay, so we are here 1 minus, I mean,
Mhm.
1 minus CV scores, and that is
Yes.
mean squared error,
Yeah.
mean square error, right? So
Right. Right.
that. So we need to
Then
plot this. There's something is error is showing much.
so this Wednesday, like again, I will go back to for meeting those people. So that's why like I have to go there and like reach there by 9:30 a.m. So that's why like we'll do on Thursday instead of Wednesday.
Pardon?
This Wednesday, I'm going back to the place where I went for interview.
Okay.
Yeah. So like I have to reach there by 9:30. So like that's why like we'll not do on Wednesday. We'll do it on Thursday.
Okay, sure. Okay. Okay, so something is error is they plot neighbors MSC. Okay. Some paper error. There's something error generated. 1 second. We are not using line space or something. Then this same code is working, giving errors.
Maybe because of different environment.
Not different. So let me. I have run here only. I don't have a backup. I think also. So. So we have MSE, and then we have to plot neighbors and MSE. So neighbors is fine. We have. So neighbors versus MSE should be plot, and the lowest the graph should be actually we should display. So, but okay, so yeah, let me check any other copy. Why it is not working at the moment?
Hey, Jimmy, I'll be back in 2 minutes. Okay?
Okay, sure.
Yes, Jimmy, I'm back.
Okay. So need to change something input. So I got a link where I've been using this one.
Okay.
So it was running right. So suddenly, so I have to change some program.
Mhm.
So it is saying matplotlib is not taking generator as a input.
You're right.
Doesn't support generators as input. So generators we are using this one.
Okay.
This one, right?
Right.
So I put in the list. So then also it's not working. Okay, so if I put what is happening. So this is actually the this one optimal K is the neighbors. This is the formula for it. Hello, this is neighbors, 35 neighbors.
Mm-hmm.
So this hello.
Mm-hmm. Yes, I'm here.
So the 35 neighbors MSC dot index minimum of MSC. So the
Yeah.
minimum should we take. The minimum is this one. So minimum number of neighbors. So that is
Yeah.
7. Here at this point should be around 7.
7, right.
So that is we plotted as a graph actually using neighbors and MSC.
Can you just go down to the chart?
Pardon?
Yeah, scroll down a little bit. Yeah. So here, the minimum. So we are looking for the minimum classification error, right?
Yeah,
So this
minimum
is
classification.
around like 3, not 7, right? The minimum point.
No,
Oh
no.
yeah, no, sorry. No, it's 7. Yeah, you're right. I was looking at the other side. Yeah.
Okay, you're
So
seeing
it's
it this way.
yeah. This is okay.
So it is
So
goes down.
around like 6 or 7, it is the minimum error.
Yes, yes. So what is giving error? Need to find out. So it is working. So suddenly rerunning it is crashing. It's saying it is not able to take generators. So this is so neighbors is fine list, right? Neighbors is list. So neighbors value is a the last I won 6 2 1. So this is a list only, right? So something happened. Oh, something error is there. I need to check it. Okay. Hamid,
Yeah, I'm here.
I need to check it. I will check it. What is that suddenly crashing?
Okay, that's fine. That's fine. You can move on to the next one.
Everything is good only. So formula is also good. So yeah, at the same shot, if you want to take in the program, I didn't use this one. So this is the
Right.
optimal key.
Okay.
So instead of so it is definitely when not looking at the graph, you can directly should do this one. So this is also giving some issue. It's saying filter object is not subscriptable. So if I stop so this neighbors is a list. So in there, so can we? I think we should convert into dictionary. I think so. Let's see. Oh, dictionary. Let's see the index. Something is wrong in this formula. So, but if I don't use also, okay, this need to be fixed. Okay, something was wrong now. Something is going wrong. I will check it. I will check it. I need to fix it. What is wrong?
That's fine. That's fine.
And the same thing is found using this one, K-means clustering.
Mm-hmm.
Remember that is unsupervised learning.
Right, right.
So that is again an iris data set. And if you see this one data frame, we loaded and column iris feature name. So this you can figure it out.
Right.
So in K-means clustering, we need to decide how many clusters group we need to form.
Right.
So here we did something like range of 1 to 11. So 10 for I in 10 number of clusters. Which one will be best options? So we don't know in unsupervised learning. So we just wanted to find a group. Let's say we have no idea how many groups can be formed, right?
Yeah.
So some information like medical disease or something. Maybe.
Give me 1 second. My
No?
son has woken up. I will be back in 2 minutes. Just
Okay.
give me 2 minutes. Sorry, I'm back.
Hello?
Yeah, I'm back. Sorry.
Okay. So here we took 10 different values of clusters.
Mm.
In K-means clustering, 10 we took. Initialization with K-means cluster. So K-means algorithm will be used. Maximum iteration 300 to, in case the K is not stabilized.
Mm.
And init number of, so you can keep it, and number of, I mean, init is how much, it was something was range of that K-means, what is the maximum number of, maximum number of clusters should be considered, one means.
Right.
So it is keeping as a 10, so it should become as same as a number of range input.
Oh, okay, got it.
And then we put a fit on the data, and then K means dot inertia. Inertia is the optimization.
Oh, okay, got it.
So this is the list This you have to take, and here we append k means dot inertia. This is a hard coding word. So this is inbuilt word. And then for the 10 different this one range 1 to 10, we put WCSS value. So when I is 1, what is the WCSS? When I is 2, what is the WCSS? So that. So now we plot it, and we got so WCSS is what is K means the inertia. So value is coming from something like this. So 10 values will be there. So 10 WCSS value will be there respective to 10 number of clusters. So and here we should consider the elbow. This is the elbow. So when there is an elbow getting bent, and after that a smooth happens, so that will be the minimum number of clusters.
Oh, got it. So where the elbow ends, where
This is
the
the first
elbow
bend,
ends,
right? This is the second bend. So you consider this one as the
okay. So second bend is considered as the ideal
so
one, right?
from the point where the your graph is getting smooth, this is the point where it is suddenly getting trying to be optimized, and here from here it is the clusters. I mean, if you see there, WCS value is not been slightly small, very slightly reducing, right?
Right.
So this is the elbow. At this what point it started. So that elbow we need to find out. This is called elbow method. So you can, this is a small piece of code, but might be tricky, and somebody can ask you in the interview also. It asks actually, it's a common question. So you can get the inertia. I think your child is getting some this one. Clusters data by trying to separate samples of n group of equal variance, minimizing a criteria known as inertia.
Okay.
Or within cluster. So minimizing, keeping the sample of equal variance means which are closer, which equal variance means what, which say makes a, you can think of having a standard deviation same, right? 0 to 1 or 1 to.
Yeah. So you are standardizing the data set.
Yes.
Yeah.
The algorithm requires a number of clusters to be specified. So grouping the samples into n equal groups of equal variance, and that is known as the inertia. Many things are there. So